Critical angle and total internal reflection are very common terms in light. Let's have a look on these terms. Let's say this is glass, denser medium, and this is air or rare medium. If a light is traveling from denser medium glass to the rare medium air, then certainly it bends away from normal, this simple rule. And at this time, let's say angle of incidence is I and its corresponding angle of refraction is represented by R. If we increase angle of incidence in denser medium, then its corresponding angle of refraction will also increase. At this time, let's say angle of incidence is I1, then angle of refraction can be taken as R1. This way, if we keep on increasing the angle of incidence in denser medium, at last a condition comes when angle of refraction becomes 90 degree in air. At this time, the angle of incidence in denser medium is called critical angle and it is denoted by C. Now, how can we define this critical angle? When light passes from denser to the rarer medium in such a way that the angle of refraction in the rarer medium is 90 degree, then its corresponding angle of incidence in the denser medium is called critical angle. At this time, this is critical angle of glass. Now I want to tell you, if you are told to draw a diagram to represent critical angle, then we can draw this way. This is denser medium, this is rarer medium. A ray of light traveling from denser to the rarer medium is passing in such a way that it makes an angle of 90 degree in rarer medium. Then its corresponding angle of incidence is called critical angle. This may be the correct representation of diagram of critical angle. C should be written as critical angle. Okay, now I want to tell you the critical angle of different medium. Have a look. Medium critical angle. Ice its critical angle is 50 degree, but water its critical angle is 49 degree. In the same way, alcohol 48 degree, paraffin 44 degree, glass 42 degree, turpentine 43 degree, ruby 35 degree and diamond 24 degree. Have you noticed this? Diamond has very less critical angle. If angle of incidence is 24 degree, then its corresponding angle of refraction will be 90 degree in air. Now I want to tell you about total internal reflection with the help of the same diagram. Here we have represented critical angle, but if angle of incidence is greater than critical angle when light is traveling from denser to the rare medium, then instead of refraction, now light reflects back in the same denser medium, and this is called total internal reflection. And how can we define this term? Total internal reflection. A ray of light traveling from denser to the rarer medium with an angle of incidence greater than critical angle reflects back to the same medium. This process is called total internal reflection. If you are told to draw a diagram to show the total internal reflection, denser and rarer medium should be shown in the diagram, and a ray of light is traveling from denser to rarer medium and its angle of incidence is greater than critical angle, so it reflects back in the same denser medium. This is diagrammatic representation of total internal reflection. I think you have noticed that there are two essential conditions for the total internal reflection. What are they? Number one, angle of incidence must be greater than critical angle, and number two, light must be traveling from denser to rarer medium. Now I want to tell you two basic characteristics of total internal reflection. Number one, 100% light reflected back in this process, and that's why the reflected light is not dim. It is as bright as the incident light, and light follows the law of reflection. It means the incident ray, reflected ray and normal at the point of incidence all lie on the same plane, and angle of incidence is always equal to angle of reflection. These are basic of critical angle and total internal reflection. Okay, I want to stop now.